Okay, guys, so a little more review on algebraically solving and how to differentiate for piecewise functions. So we have a function f of x that has three different equations with three different mini domains. I'm going to highlight each one separate so they're easy for us to notate without having to read out all the numbers. So I'm going to do purple, green, and pink. Green and pink. So we can discuss openly about which one goes with what. So f of -4, as we've said before, this is saying basically f of x, we plugged in the place of x a -4. So this is the same as f of x equals, but x at this point is -4. So we have to decide, is -4 less than or equal to -2, between -2 and 3, or greater than 3? So I mentioned in a previous video, it's probably worth some of your time to have a number line present, either just maybe in the back of your notebook is a great place to print and tape one, or to draw one so you can use it all the time and don't have to redraw it. But so our purple function is going to be a closed circle at -2, and then it's going to be all the numbers that are this way if we were to look at it as a flat number line versus your coordinate plane. But it's the same difference, you're still looking at the bottom. So your green is going to be an open circle at -2, so just a parameter, but that guy doesn't count. And then all the way to +3 with a close because of your equal to. So it's all the numbers that are going to be in here are going to be green. And then open circle at 3 for pink, and everything to the right. So +4, 5, 6, 7, and 8 are going to be used for that pink function. And again, this is just a one-dimensional, but look at it as though it is the x-axis, and then there's going to be a graph around it. So lines, you have a linear equation up here because it's 2x plus 8. So purple is going to be linear. It's positive, so if you were to graph it and look at it, it should look like a portion of a line that should look like that. X squared minus 3 should be a quadratic. So it should be a parabola or a portion of that parabola within that domain. And then last but not least, that is a radical. So that's the ones that look like this. We haven't gotten them into them very in depth yet, but you will. But you just need to know vaguely that it is not going to be a parabola. It's not going to be absolute value. So as far as when you're looking at your graph, if you were to have to find them, that would be helpful for some of us. So I'm sorry, back to the f of -4. So deciding -4 is going to be part of our purple. So we're going to use our purple function for this one, that linear 2x plus 8. So it's going to be 2 plus 8. And we're plugging in that -4. So 2 times -4 is a -8 plus 8, which is going to be 0. So as a coordinate, that means when x is 4, y is going to be 0. Just depending on how they notate your answer choices or how they word the question. But so the question is, what is y when x is -4? So that's what the verbal question is what is y when x is equal to -4? So f of 6 is greater than 3. So that's going to be in their pink function. So we're going to use our pink function here. And that means we're going to do the radical plus 3. And then we're going to plug in that 6 in the place of x. And then we're going to solve it. So 6 plus 3 is 9. So we're going to take the square root of 9, which is going to be 3. Which means when x is 6, y is going to be 3 for this one. Or the output is 3, or y equals 3, or f parentheses, f of 6 is equal to 3 would be another way to say it. F of -2. So be careful because it looks like it could be the green or the purple function. But in the green function is not actually -2. Remember, that's our open hole up here for our green function. So we're going to use that purple linear function again. So 2 times whatever value they gave me plus 8. So 2 times a -2 plus 8, which is going to be -4, because positive times a negative gives me a negative, plus 8, it's going to give me a +4. So as a coordinate, when x is -2, then y is going to be 4. So f of -2 is going to equal 4 if you're reading it the way it's written here. So this is f of -2 is equal to 4 would be the sentence form of that answer. And then last but not least, f of 0. So that does fall, and you can see it up here real easy in the green function. So we're going to take our green one, so that's that quadratic. So x squared minus 3. And they want us to find out f of 0. We're using our green function. So we're going to plug in that 0 in the place of x. And 0 squared is 0. 0 minus 3 does give us a negative 3. So that means that when x is 0, y is going to be a negative 3. And you can plug these in and check them, which is basically what you did anyway. But you can plug your function into a calculator and get a table. You can plug it into Desmos, which I'll show you in the other video. But you can check them that way. Absolutely. And if you get a graph of this, then that's the other way to find it. All right, so you will see some that are f of x, g of x, and h of x. So in that case, each one is different. So it's talking about, like, this could be Frank, this is Gertrude, this is Hilda. So Frank, Gertrude, Hilda, when you come over to your questions, you want to make sure not only do you still have to differentiate like we did in the previous problem, but you can't be looking at Gertrude's equation to answer a Frank question. So again, Frank, Gertrude, and Hilda when I'm talking about it, so you know who I'm talking about or what I'm talking about. So Frank of 4, so f of 4, we're going to go to function f of x. So Frank, and then we need to decide if positive 4 is less than 0 or greater than or equal to 0. 4 is greater than or equal to 0, so we're going to use that quadratic, and we're going to plug in that value of a 4, because that's what they want us to solve for, and we are using the functions with f. So 4 squared is 16 plus 1. So the answer is going to be 17. So when x is 4, y will be 17. So that coordinate should fall in the table of that function when x is 4. All right, so then Hilda, 12. So we're going to go down here to Hilda. Is 12 less than or equal to 1 or greater than 1? 12 is greater than 1, so we're going to use 3 times our x value minus 5. And in this case, we want our x value to be 12. So 3 times 12 is 36, minus 5 is going to give us 31. So when x is 12, y is going to be 31. And so again, you can see these answers as coordinates. You could see it just as y equals 31. You could see it h of 12 equals 31. The answer choices could look lots of different ways depending on the formatting and the teacher or the worksheet or program that's being used. All right, I'm going to slide him up. So we're looking at Gertrude now. So we're going to look at our functions in the middle. That's g of 4. So we're going to look at our g functions. And is it 4 is less than negative 4 or is 4 greater than or equal to negative 4? 4 is greater than or equal to negative 4. So we're going to use 1/2 times our x value minus 2. And we're going to plug in that positive 4. So 1/2 of 4 is 2. And 2 minus 2 gives me 0. So as a coordinate, when x is 4, y is going to be 0. Or g of 4 is equal to 0. All right, and then Hilda, 1. And pause the video at any time if you want to try this by yourself, because now's the time to mess up before the quiz. You got plenty of time in notes and practice to mess up. That won't hurt you. Quiz is when you want to know what you're doing. So you want to mess up, figure out your mistakes, and fix it before it's like go time, especially EOC go time. So Hilda, 1. Is 1 less than or equal to 1? Or is 1 greater than 1? So be careful because they're both 1s and we're going to jump. But we need that equal to. So that means it's going to be negative 7. There's not an x there. There's not a variable of any kind there. So that just says all numbers less than or equal to positive 1. The output is going to be negative 7. So as a coordinate, it's going to be 1, negative 7. Or as the answer by itself, it's negative 7. Or h of 1 equals negative 7. But the answer to that question, again, what is y when x is 1 for the h function? Y is negative 7. All right, so g of negative 6. So we're going to go to Gertrude's. Negative 6 is greater than or equal to negative 4 or less than negative 4. Negative 6 is working towards the left, so that is less than negative 4. So we're going to use negative times our x minus 3. And I use those parentheses to make sure in this exact case that I don't leave out one of the negatives, because double negatives makes a difference, and that actually becomes a positive 6. Minus 3 is going to give us a positive 3. So when x is negative 6, y is going to be positive 3. F of negative 10, we're going to go to our f function, Is negative 10 less than 0 or greater than or equal to 0? Negative 10, again, is further down left on our number line, so it is going to be less than. So we're going to use 2 times x minus 4. We're going to plug in that negative 10, which is going to give me a negative 20 minus 4. It's a negative 24. I borrowed $20. I borrowed 4 more. I owe you a negative 24, or I owe you $24. So as a coordinate, negative 10, negative 24. All right, down here at the bottom, same thing. It just looks scarier. Your functions, I don't know that I can get them all on one page. Let's see if I can back up a little bit and get you where you can see it all at once. So just like we did for the 6 prior, you're going to do the same thing, but then we have to actually solve like another problem. So this is 2 times f of 4 minus g of 0. So we're going to, one thing at a time. So f of 4 means I'm going to go to function for f, which I already did it, and I know that it's 17, so that equals 17. So it's 2 times 17, because we already solved it up there at the very first one, minus g of 0, which we haven't done yet. So we're going to do g of 0. So we need to go to the Gertrude function and decide, is 0 less than negative 4 or greater than or equal to negative 4? 0 is to the right of negative 4, so it is going to be greater than. So we're going to use that 1/2 function. So to solve for 0, we're going to do 1/2 times 0 minus 2, which is going to be 0 minus 2. So it's going to end up being a negative 2. And again, using those parentheses to make sure you don't lose those double negatives. 2 times 17 is going to be 34. Yep, 34. Minus, or it actually becomes a plus because negative negatives. So our answer is 36 for that. And you're just solving the equation using function notation and getting the output values. All right, so the next one, again, pause it whenever you want. This could also be written h of 0 divided by 2f of 16. So h of 0, we're going to go up here to Hilda. Is 0 less than or equal to 1 or greater than 1? 0 is less than or equal to 1, so we know the output is negative 7. So that top of that fraction is negative 7. And then we need to do 2 times f of 16. So f of 16, if we go back up here to Frank's function, is 16 less than 0? Or is 16 greater than or equal to 0? It is going to be greater than. So we are going to have a holy moly big number. But we're going to do it anyway. So square it, and we're going to put a 16 in there. And then we're going to add 1. So 16 times 16, I'd love to tell you I could do that in my head. I don't know it. So 16 squared, 256 plus 1. So it's going to be 257 on the bottom. You do want to see if you can reduce that. And it cannot be reduced, so it is just an ugly answer, but we are done at negative 7 over 257. Same thing, it's just 3 different parts now. So just start left to right and work your way through slowly. So I know I'm going to have 1 at half. I'm going to have an answer minus an answer plus 3 times an answer. And that's me going for Hilda, Gertrude, and Frank are going to go in those parentheses when I'm done figuring them out. So Hilda, 7. I'm going to go decide, is 7 less than or equal to 1 or greater than 1? It is greater than 1. So that's going to be 3 times 7 minus 5. That's 21 minus 5. And 21 minus 5 is going to give me 16. So we're going to put a 16 right here. And then we have Gertrude. So we're going to go up to Gertrude's function and decide if negative 5 is less than negative 4, or is it greater than or equal to negative 4? It is less than because it's on the left. So that means I'm going to have a negative times a negative 5 minus 3. So negative, that's like a negative 1. So that makes it a positive 5 minus 3 is going to give me 2. Positive 2. Because if I have $5, I lose 3, then I have 2. And then last but not least, so Frank's function, we're going to go up to our f and decide, is 2 less than 0 or greater than or equal to 0? It is greater than. So we're going to do x squared plus 1. And in this case, the x value is a 2. And 2 squared is 4 plus 1, which gives me 5. Now, you've done a lot of math, but we're not done yet. We still have some things to do. So we need 1/2 of 16, and 1/2 of 16 is going to be 8, minus, we're going to hold on to the 2 for now, and then plus 3 times 5, which is 15. And this is just knowing your orders of operations, or remembering your orders of operations. So PEMDAS is what that was called. And I'm writing it all the way out so you see all of it. So 8 minus 2, 6 plus 15 is going to give you 21. So the answer to that, guy, is 21. All right, guys, great job. Hope you got all that down.